Yes. All right, let's get this show on the road. Hey, welcome everybody. Thank you for coming. This is the Seattle Postgres user group. My name is Jeremy. This is Lloyd. Man, this is great to see everybody out here tonight. I'm going to run through a couple announcements real quick, and then we'll introduce our speaker and get everything going. And then Lloyd has a few things too. So my stuff real quickly. If you didn't see the sign, bathrooms are just out the back door here in case anybody needs to find them. If there were name tags, I think everybody got a name tag. If you didn't, please grab one. It's just kind of a nice way people can kind of see who you are. Sign-in sheet again, I mentioned that earlier. Usually I have a stack. So we have a table called the library table. I just want to mention that. You are welcome to take a look. There's some interesting books. You can borrow one. This is just kind of a borrow library. Please bring it back someday. Stick your name and a little bit of contact information on the clipboard if you borrow a book. If you keep it for a really long time, like a year, I might eventually call you and ask how you're enjoying it. Harry, did you learn anything interesting in the Postgres internals book?
I learned a lot of it was interesting. I didn't actually need it for work, as it turned out. Most of what I was doing was wire protocol level stuff. But yeah, the internals of how a system. I mean, I didn't read it in depth.
Yeah.
I read the parts that were related to the query processor. And, that's there was an article on Hacker News today about some of the new async stuff coming in DG18. I was reading that today. It's the same kind of like, this is really cool to understand, even if it doesn't really affect me on a day-to-day basis.
Nice. Yeah.
And a great book.
A bunch of it. So that was the query processing internal chapters that you're spending a bunch of stuff on. That's just an example of what you can find in our library. All kinds of really cool stuff.
And he'll hunt you down and give you bring it back. That's why I'm here. I did bring the book back.
All right. Let's see. Sometimes I have a stack of printouts of something that's called the happiness hints over there. I don't know if there are any. You're welcome to take one of those. It's just kind of self-promotion, but it's just kind of a collection, mostly not original ideas, but it's just stuff I've collected that I've heard people say are good ideas for Postgres. So you can take a look at that. My other two announcements, if you didn't see my message that I sent out to the meetup group, is that I'm like the most caught up that I've ever been with posting videos on YouTube. So I'm really excited. I've actually got Jonathan Katz's video posted from last month, and usually I'm like 3 months behind with all the editing and stuff. So yeah, YouTube site's up to date. If you missed last month, or just go check it out. There's a bunch of really great talks on there. And then the other thing is, I actually, on the same theme of actually being like caught up, it's amazing. I've got next month's posted, like the date is posted, and I also have, we're gonna have we always, for many years, we have always kicked off the summer with a barbecue. You can look right out that door. There's a patio. There's a deck right out the back on this building. It's a gorgeous view of Lake Union. It's got a big old grill back there. Usually Lloyd brings a bunch of stuff. We grill it up, and we just kind of hang out in the patio. So kick off the summer. It's already posted on the website. Everybody's invited to come join us out there. Bring your database nerd friends, or somebody who's curious, and we'll geek out about databases and just grill and hang out. And that's how we'll kick off the summer. First Thursday of July. I think it's July 3rd, right?
Yes.
Yeah, July 3rd, 6 o'clock is what I posted it for. Hopefully that's the right time. So that's what I got. Lloyd?
Yeah, in fact, I was going to mention about that also. So I normally bring hamburgers, hot dogs, turkey burgers for the people who don't eat beef, and veggie burgers for people who are vegetarian. I'll also bring a watermelon, but then everybody else is welcome to bring additional stuff. And we just say it's our social month of the year, because historically it was our lowest attended presentation for July. So that's why we created this social event in place of it. And everybody's welcome to come. It does not cost anything to attend it. So everybody's welcome. And it's up on our 5th floor, not this floor, but it's up on our 5th floor. And if the weather is bad, we actually have an inside room just inside with big windows looking out. That has the kitchen area in it too. So good weather or bad weather, we'll have a great time up there. And so that's PostgresConf last month was great. That was down in Orlando. I was there for that. I'm one of the organizers, if you don't know, on that one.
Did anybody here attend PostgresConf in Orlando? I'm curious. Dion did. Anybody else? You have a good time? He nodded.
Yeah.
Right. And the other one coming up is Gwen. You're actually speaking next week, right?
Yeah,
Also?
that's the developer conference.
Yes.
In Montreal.
And that's a really good conference to go to. So these US conferences, I go to teach at. The developer conference is where I go to learn at. So it depends on, different types of conferences are geared towards different types of people. If you are working with the Postgres as a user, as a developer of applications, the ones in the United States are great. If you really want to understand the inner workings of Postgres, the developer conference is the one to go to. And there's also a side conference the day before that conference. It's the Postgres Extensions Conference. That is a brand new conference, as headed by Yuri, and who lives up on Vancouver Island. And it's going to be discussing all about the Postgres extensions ecosystem and how to build the extensions and stuff like that. So that's the day before the developers conference. So yes, so you can Google that one too.
The developer conference is next week.
Yeah.
Okay.
Yeah. So yes, and the day before is the extensions conference. So yeah.
All right, cool.
I think that's covered everything. Yeah, so that's covered everything.
And then next month, like I said, just posted on the website. I encourage you to check it out. It's going to be a talk on the topic of, we have a guy coming up who's going to talk about a Rust language Postgres extension that he built around, it's around AI capabilities that he's sort of plugging into Postgres. That's the high level overview that I have. I'm super curious to hear more about it, but if you're interested in any of the words that I said, either AI or Rust or extensions or Postgres, I think it would be a great talk. I tried to get all those words in the title too, so that you'd know what was going on. So that's next month. All right. And now it's time for me to introduce our speaker. So Gwen, thank you for coming up to Seattle today to speak. Gwen is a co-founder of Nile, which you can find at the THE, like the one and only Nile, like the river, .dev. Gwen's got 20 years of experience, more than 20 years of experience working with code and customers to build reliable and scalable architectures from Oracle through Hadoop, through Kafka to Postgres. Gwen is a committer to Apache Kafka, author of Kafka, the Definitive Guide, and you can find her speaking at tech conferences or riding her bikes on the roads of California. Thank you very much, Gwen.
Thanks for inviting me, Jeremy. Really awesome to be here. So the talk I'm giving now is, you can almost think of it as a preview for the talk I'm giving next week at the PGConf developer conference, which means that I am going a bit deep. I am talking a bit more maybe than expected about internals. Definitely help me prepare. Ask me hard questions. Kind of come up with the hardest you can think of, so I'll feel like I'm well prepared. And any feedback, stuff you wish I would talk more about, stuff you wish I would skip over because everyone knows it and it's boring, I would absolutely love that. This will be extremely helpful. So I thank you in advance. Nile, the company me and my co-founder started 3 years ago. We had some pivots, but as of 2 years ago, we have decided that we are re-engineering Postgres for multi-tenant applications. And I'm going to explain what are those multi-tenant applications and why do we think they need re-engineering. And that will be like the first 3 slides. And then the rest would be how we built this platform that actually scales for millions and millions of tenants, and all the issues we ran into and all the trade-offs we had to take and all the problems we met along the way. That is the fun part. Okay, so he already said all that, so I can skip it. And so basically, I'm going to start with multi-tenant data architectures, then talk about how we built Nile, kind of go through some flows, how everything works, and then I'll talk about what are the limitations, what we don't love about our solution, and where we're thinking of taking it next. So if you go to our website, you'll see in the title that Nile is a Postgres re-engineered for multi-tenant applications. What in the world can we mean by that? Well, first of all, multi-tenant applications. we're talking about a scenario where we have one application stack serving large number of customers. Large number can be probably over 100 and then going up from there. And those are quite common. Out of curiosity, how many of you are working on something that you would call a multi-tenant application? 1, 2, 3, 4. Okay, I'd say about maybe a third to half of you. So good number. They're common. They're not exactly rare, and they've been common since the early 2000s. So we're kind of like a quarter of a century of having multi-tenant applications. And it's still hard to scale them. And it's still hard to manage them. And every time any kind of application goes above a certain size, there is the big blog post of how we sharded it, or how one of our tenants caused us an incident and how we took 6 hours to recover from that. All those things are not uncommon and a big part of the motivation that triggered us to try to do something better. So basically, when you go to use Postgres for multi-tenant application, you have a choice of architecture. One option is to have really isolated tenants, maybe a database per tenant or even a schema per tenant would fall into this model. And then if you look at the tables, they all look like normal tables, and the application layer has to figure out which one of those to talk to for each customer. So all the routing. There's a lot of pros for that. You get good security pretty much for free. If one of your tenants regrets their life choices, calls you up and says, I want my data from 6 hours ago, it's very easy to get this one tenant their data from 6 hours ago, not impact anyone else. If they tell you the upgrade window of Tuesday at 6 p.m. is not good for me, can we do it Wednesday? No worries. You have all this flexibility to treat each and every one of your customers as a special snowflake. But on the other hand, you have hundreds, potentially thousands of databases to manage. You have to upgrade thousands of databases. If you need to do a schema update, you have to kind of figure out how to do it across all those. And also, you have to figure out in advance how big every one of your customers is going to be. If someone just suddenly spikes and becomes really popular, now what do? They're on this machine, and you don't necessarily have tons of headroom for them. Sorry. The other option is pooled model. In my experience, this is actually the more popular option of the two. You basically have one schema, and you shove all your customers into it. The application has a lot of code that says where tenant ID equals X. You don't have a lot of isolation. You're always, a developer doing a typo or an LLM hallucinating away from leaking data from one customer to another, so it's a bit risky. On the other hand, much simpler to operate. The entire idea of I put all my eggs in one basket, and then I keep really good eye on the basket and take really good care of this one basket. It kind of works for a while. One of the big problems here is how do you scale out? And the normal technique is to start sharding it and having more and more machines with this model inside them, and then you have some of the pain of the previous model where the app has to route them, and some of the pain of having to manage a bunch of databases, but hopefully not too much of each. So you kind of have what is maybe a good combination of both. At Nile, we thought that we like the idea of having a combination of both, but we think we can do better than the standard pool them and then scale out by sharding. So when do you need to scale out, really? Postgres is really good when you put it on a big machine. You can have a lot of tenants on one machine. And I was reading a blog post from either Figma or Notion, but they basically managed to be a $2 billion company on a single Postgres, with every single one of the customers on a single Postgres machine, which hopefully was failover, but they didn't talk about that in that blog. So you can definitely go a lot by just going up. When do you run out? Usually, you'll see auto vacuum taking longer and longer, maybe not completing, maybe you start being worried about wraparound of your transaction IDs. Sometimes it's the number of connections that becomes completely unmanageable, or the size of memories that each connection needs to hold in order to have the entire catalog. And there could be other things that are under contention. One of the things that sometimes come up is that Postgres efficiency of managing the buffer pool only goes up this much. You can get from AWS machines with 4 terabytes of memory if you pay them enough, but you're not going to be able to use all of them for the buffer shared pool in Postgres. So at some point, if your business is successful, you will need more machines. And you have to do it the right way, because if you break down Postgres into a bunch of machines, and then every machine, most queries have to touch more than one machine, you haven't done much. It's not any more scalable than it used to be. It is slower than it used to be. And it's almost like the database version of a distributed monolith kind of thing. Like you think you're distributing a system, but actually it's still very much tied together. Why does this matter? Well, up till now, and I'm not sure if someone hinted that it's about to change in Postgres 18, but Postgres protocol doesn't do pipelining. Meaning you send one query, you get a response, you send the next query. You do that on each connection. Meaning that if you add few milliseconds extra latency of each one of your connections, it just keeps adding up. It gets slower and slower. The other thing you may discover is that ORMs tend to be extremely chatty. You think you wrote something that should be one query, and then you actually look at the log. And it sends anywhere from 3 extra queries to discover something about your data type to n+1 extra queries because it does not believe in joins. So this extra latency gets extra boost from our ORMs. And the last bit is that if you need a certain level of throughput for your system, and you just added tiny bit more latency for every connection, in order to maintain the previous latency, you're going to need a lot more connections. This is Little's law. You're not allowed to have a presentation about performance or scalability without mentioning Little's law. It's from queuing theory. Little's law originally, it was way before there were computers. It talked about stores. If you want to know how many customers are in a store at a given time, you watch how fast do they come in and how long does it take to serve a customer. Same thing, if you want to know how many concurrent queries are being processed by a database, how fast do they come in and how long does it take to run a query. If you need them to process the same amount of queries and it takes you slightly longer, you need more of them coming in at the same time, meaning more connections. But whoops, connections take memory, connections take resources. So you actually get a bit slower. Now you need more connections to maintain throughput. This whole thing can blow up. So it's very important to constrain latency while scaling out your database. And the way out of it is if you look at a typical query in a multi-tenant system, most of them, as I mentioned earlier, have where tenant ID equals something. So most of them will, no matter how complex, how many joins, how many recursive, whatever, they are going to touch data for one tenant. Meaning that if we can keep all the data for one tenant together, you can spread out those tenants in as many machines as you need and get scalability that way, which is basically what we did. So our idea was to take Postgres and turn the concept of a tenant into a first-class concept in Postgres. We call it virtual tenant databases, where we separate the data for every tenant. I'm going to show you exactly how, and then we scatter them around as needed. So we're going to start with a very high-level view, and I'm going to drill down, and then I'm going to walk you through some operations. So at a very high-level view, we have the concept of a logical database, which is basically supposed to look exactly like a normal Postgres. There are some caveats. I'll get to them at the end. This logical database is made up of a lot of tenants, and they can be on as many different physical Postgres instances, physical machines as needed. Now, when we architected the system, in every system architecture, and I'm sure most of you look more or less my age, so you probably know that whenever you architect a system, there are some considerations that just have overwhelming impact on the design. That once you take those key requirements, you're like, okay, the only way to solve for all of those is this. And that's pretty much what happened to us. So here's what we wanted to do. First of all, we wanted to provide security and privacy. It was important for us to really isolate the data for every tenant. Then we wanted to make sure that if you do a query on a single tenant of the type that we think is very common, it should have the performance as if you connected directly to one database that only belongs to that tenant. It shouldn't suffer any slowdown because there are other tenants on the system. Third thing we wanted to support, sometimes, hopefully rarely, you're going to need to do a query that touches multiple tenants. Maybe you need a report across all your tenants, who is the top 10 customers for the company, kind of thing. We wanted those to be possible. They are not going to be fast, but they're going to be possible. And if you need a lot of those, then Nile may not be the right system for you. Fourth thing we wanted is the ability to move tenants around. This is critical because we don't know in advance which one of them is going to be very big or very noisy, very active. We may need to give someone their own machine or just move them aside temporarily to protect others. So this was a big one. And then the last one was we wanted to be able to support customers with million tenants. We ended up being able to support 4 million, but the goal was to support at least one. So if we drill down a bit into our architecture, so that I have a cool laser pointer here. So we have a proxy up there. Okay, we have a proxy up here, and all requests, queries, everything comes in through that. And then we have serverless compute. This is where tenants land if you don't tell us anything else. We also have provision compute. So our customers can tell us, hey, Nile, I want a machine with this many CPUs, that much memory, and put those tenants over there if you want to micromanage your tenants a bit more. We have transaction coordinator. This coordinates the actions that happen across tenants. Every DDL goes across that because we believe that if you do create table, you actually want every tenant to get this table and not just some of them. We have metadata store for things like who exists where and things like that. And then we have our own page service. We do not use Postgres default storage. I'm not going to talk a lot about our page service, but it's basically a memory cache layer above S3, which is amazing storage, highly available, resilient, very cheap. It has downsides. It's slow. Hence our layer of cache immediately above it. But other than that, it's pretty awesome. And the fact that we have our own storage service is basically what allows us to move tenants around without copying data in all directions. Okay, if we drill down even more and look at a specific tenant, or in this case, 2 specific tenants, you'll see that each tenant has its own table space. Table spaces are very useful for separating the data that is being stored, but we mostly needed it for the identifier. It turns out, if you look at Postgres Storage Manager, it knows basically nothing about the data. It doesn't know about table IDs or index IDs or partition IDs or nothing of the sort. What it does know, it has file identifiers and it has table space identifiers. We basically hijacked the table space in order to serve as our link to the storage layer. And you can see that each table space is basically translates SlateDB is the technologies that we use for storage layer. It's basically a close relative of RocksDB, if you're more familiar with that. And we basically treat it as a file system. We mapped every operation in Postgres Storage Manager, like create, extend, write, all those things we support. And so basically all those table spaces get stored there. And then in each table space for each tenant, we have partitions. So somewhere there is a larger events table. There is a partition for tenant 1 to 3 and partition for tenant 4, 3, 2, each on its own table space. Why do we need partitions? Partitions is what actually gives us the separation that there are specific blocks on disk and in memory that are dedicated to this tenant and other tenants are not going to touch. Now, if we zoom out a bit and look at a specific table across all tenants, you'll see that we have a really weird structure for distributing it. So we have the partition table on every one of the computes. And then we also have a base table. I'm talking about the table inheritance feature of Postgres. And inherited from that is a foreign data wrapper table that points to the remote partition tables elsewhere. Why in the world would someone do something so weird and so complicated? You may ask yourself. The reason we ended up with this admittedly weird structure is that you really cannot have a million partitions in a single table. This is not going to work. Even if some of them are remote partitions that use foreign data wrapper to point to other databases, it's not going to matter. It's going to bloat up your catalog cache, which means that also bloating up your memory for every single one of those connections. It is going to have awful overhead for query planning. I think we tested and at 10,000 partitions, our select, just the planning phase of a fairly simple select got up to multiple seconds. This is not going to end well kind of scenario where, okay, we have to limit the number of partitions on each machine. And in order to still allow for those cross-tenant queries, we added the foreign data wrappers that point to the partition tables on other machines. Now, I'll talk a bit more about how does it actually optimize in practice when I get to talk about what happens when you run a query on this. Okay, so let's look at some operations. The first one, what happens when I want to create a tenant? Well, what my customers do is basically connect with pSQL or their favorite editor and say, insert into tenants, here's the tenant name. This goes through a proxy, which intercepts it and calls tenant placement logic. At this point, tenant placement is basically going to pick a random serverless compute to put your tenants on. We don't know anything about this tenant, so unless you told us otherwise, put it on that specific machine, we're going to pick a random one. And we're going to generate some IDs. All this goes to our meta store. So this is the tenant ID, this is the table space ID, it's going on that machine. If you decide that you want it in a separate region, like in Europe, there will be a region identifier there as well. Once we have all that, we are creating the table space. The fact that we're creating the table space is one of the big reasons that our proxy has to coordinate the entire thing. The create table space cannot be part of a transaction. This is very annoying. This is one of the few DDLs in Postgres that are not transactional. And basically everything that we have at lower layers is either transactional by design, like the transaction coordinator, or does not even know that the metadata store exists in case of our extensions. So we have to coordinate this one on the proxy layer. Once the table space is created, We forward the insert into the correct database. The tenants table has a trigger. We trigger and create all the partitions for every single table that exists in this database. Note that if there are a lot of them, insert into tenants will be surprisingly slow because it has to add all those partitions. Yeah.
The 456 you had on the, is that the ID that the system came up with for the tenant ID?
Yeah, it's an example ID.
Yeah.
We normally use UUIDs,
Yeah.
but yes.
But that's the primary, that's like the tenant ID in the metadata store?
It's the table space ID.
The tenant space.
And we actually do base something encoding to it. We try to get it into a printable string that is as short as possible. And the reason is that you only have 63 characters for an identifier. We didn't want to eat too much of it. If we were to put a full UUID there, it would eat a lot of it. How do we add partitions? We do a create table, and we do create table like the partition table. So it will be identical. We get all the indexes, all the constraints, everything that we need from the top level table. And we added another keyword that's specifically in our version of Postgres. It's a patch, and it's including physical layout. What do we mean there? I'm going to jump ahead a bit. Remember that I have a requirement to be able to move tenant from database to database. What if this tenant existed in a database and the events table, actually 3 days ago, I dropped a column from it? Well, dropped columns in Postgres are not actually dropped. If you look at PG attributes, you'll see underscore underscore dropped something. So they kind of get marked as dropped. They lose their name, but they're still there. More important, the data on the block that belongs to that tenant in their table space, it's still there. And if you going to do vacuum fuel, which you probably wouldn't, because why would you subject yourself to this downtime? Then it will be replaced to null, with null. But the idea is that there used to be a column there, never goes away. Now, let's say that I've just added a new machine and I want to move this tenant to a new machine. If the events table on that machine does not have the old previously deleted column, then the blocks I'm going to move over do have this column. It's basically not going to start. I'm going to crash Postgres. Not a good idea, not what I'm trying to do. So it's super important for us that whenever we create a table, whenever we create data blocks, everything will be compatible with each other. So including physical layout basically means please include columns that were already dropped. And we implemented it in a Postgres patch, and it was shocking to me. Basically, it was 200 lines of code, and tests were most of it. It was maybe 50 lines of code for the logic of if you see those keywords, do not skip the deleted columns. So we have a table that is even more identical to previous tables than you would normally get. And then we do attach partition. Attach partition is awesome, by the way. If you have partitions and are not using it, this is the way to add data to an existing table without taking access exclusive lock. Always a good idea. So it's the lowest interruption way to get data into a partition table. Okay, that was creating tenants. How do we query this thing? We have basically 3 query modes. For a normal select, we ask customers if you want to do a select just on a particular tenant, tell us in advance which tenant. So you do set nile tenant ID, and then you don't need a where clause. You could have a where clause, you don't need it. If you have a where clause, we make sure they match, and you get an error if you you say you're going to work on one tenant and you're working on another, we will send back an error, but you don't need to have a where clause. The gateway gets the set Nile tenant ID. It knows where every tenant is placed. It will redirect you to the right database. And then we have an extension that takes this select star from to-dos. It knows what tenant you're trying to query, again, because of the set Nile tenant ID, and it will replace it with that specific partition. This means that you're not querying an entire partition table with thousands and thousands of tenants. You're querying one partition, which is the one you need. We are bypassing the query planner, and the reason we are bypassing the query planner is that in simple queries, like the one I show here, it's going to do a good job. But if you have a complex query with a bunch of joins, etc., it is going to take a long time to do a good job. And we don't want it to take a long time. We want it to be as fast as if you're connecting to one database without all those partitions. So we're doing the replacement. And another interesting fact about Postgres, the query planner, this is an extension. We have to hook into the query planning lifecycle. The query planner does not have a hook before it does what is called analyze and rewrite. Rewrite means that every table name is replaced with an OID. We only get our hook after that. So we basically do some kind of an OID replacement over there. Okay, what if we want to do an insert into that table? The insert doesn't have a workload. You could do set tenant something, but you don't have to. You can also specify the tenant ID in the insert itself. Our proxy is capable of parsing DMLs, pulling out the tenant ID, and then doing the insert again directly on the correct partition. We're bypassing all the query planner, all the partitioning logic in Postgres there. The impact here is not really all that material. I mean, the Postgres partitioning, it's range partitioning, it does a perfectly good job here. But we wanted that, we needed to pass in the tenant ID anyway to make sure that you are not trying to do any kind of DML across tenants, like move data from one tenant to another would be a bit of a problem. So we are also doing this small optimization. And last but not least, cross-tenant queries. Oh, there's a question. Okay. Yeah, cross-tenant query. Again, we hope you're not doing too many of those, but sometimes you want to run something across all your tenants, like select star from to-dos without any particular tenant. In this case, the proxy does nothing. It routes you to somewhere pretty random. And we replace the select star from to-dos with a union. Half of the union is query the partition table, and the other half, the base table of the inheritance hierarchy that points to all those other databases. And this is basically the reason that the entire inheritance hierarchy has to exist. So we can do select star from to-dos, union all, and select star from those remote to-dos. Now, note that for every machine, the local query planner is going to figure out all the partition access. But everything else, it looks like a single table. So the firm data table that points to all those remote machines, it looks like it's pointing to one table. My local machine knows nothing about the fact that over there are partitions, which means that we're essentially doing push down for the planning. So instead of forcing one machine to do planning for 1 million tenants, we're forcing maybe 100 machines each to do planning for 10,000 tenants. Again, I'm not saying it's going to be fast. And if any one of those 100 machines is under load, it's going to take even longer. If it's down, then we're not going to let you do that at all. But it allows us to support these operations that was important for us to not prevent from existing. Oh, a lot of them, yes.
Other than this, what is the reason for using partitions instead of just creating multiple tables?
So we get a lot from, we could have done multiple tables, but we do like the fact that we get to use the planner that if we need to add a column, like all the DDL operations, we don't have to actually do it one after another.
But then you wouldn't have to create your own query planner if you just use one of the tables.
We didn't feel like we created our own query planner.
Or like
We saw this as the option that actually allows us to use the query planner to query partition tables with relatively minimal replacement. Again, like it's because of the ways of this overriding the planner and hooking into the planning process, basically in the middle, after rewrite happened and before actual planning happened, we felt that this was actually the easiest option. The alternatives we considered was to actually make it look more like a single table, not even use partitioning, and then like maybe the storage layer, have it use the tenant ID to pick the correct storage. It had a lot of benefits, like you have a much smaller catalog cache, but then we would really need to not just write our own planner, we had to write our own vacuum. It looked like a much bigger project than what we actually wanted to tackle. But yeah, for us, this was actually the simpler option. I would say.
DDLs would be executed across all.
Yeah, exactly.
You can go first.
Thank you.
Yeah, so two-part question. One, it looks like from your query up there that the way you do a cross-tenant query is not specify tenant ID, and then by default it's a cross-tenant query. Is that true?
Yes, that is true.
Is it a use case that you all want to support, where your customers have access to query their tenant, query the database directly with their tenant ID? Or is this all assuming that there's kind of one application stack running on top that's doing all of the queries?
We actually, so this was a very common request.
Yeah.
So as of 2 weeks ago, I think, we actually support that. So
Cool.
you can get a connection per tenant, and if you use the connection string per tenant, the proxy will route you to that tenant directly. It will set all the configs that are needed, and the only main thing is that after you did that, you're not able to do set tenant. we basically lock this
It's
connection
locked
to
in.
one. Yeah, exactly.
Is that tied, so for that use case, is that tied into like access control somehow? So the user that you're logging in as is tightly coupled to a specific tenant ID in that case?
At this point, our user story is a bit more complicated than that.
Gotcha.
Our proxy basically connects to everything with the same Postgres user, which is something that we are now thinking about replacing. You can specify a user ID, like set nile user ID, and then we make sure that the user is a member of that tenant, that it actually has access to that tenant, and we fail all queries if it doesn't. So we have something, but it's very coarse. It's nothing lower than the tenant level. So
It's a fairly different use case too, than it sounds like what you're
Yes.
talking about. It's cool that you guys are looking to support that. Thank you.
yes.
If you don't mind sharing, how does the proxy work in a very specific, in a very high level way?
Yeah,
How does it practice?
absolutely. So there is two important parts to it. Part of it is the protocol handling. Basically, we have a kind of a state machine in the loop for just if you get a bind, we know to create something in the cache because it's going to be followed by describe and so on. Parse followed by bind, all those things we kind of cache. And then we obviously have a lot of caching for which tenant belongs in which database, so we can do the routing. All the parsing is done with an amazing library called, I think it's called libquery or libpq, one of those. It does both parsing and deparsing. Yes. So basically we take a query, we break it down, sometimes in order to just pull out information, like, oh, this is the tenant in the insert, now I know where to do the routing. And then we can also make some changes and on the parse tree itself and combine it back together into a query that will then forward to Postgres. We used to do a lot more of that, but then we were like, okay, but we also have our extension, which is way more efficient, and now we do it in two places and it makes no sense. So we're trying to do less in the proxy and more in the extension. Yeah,
Is that the library from PG Analyze?
exactly that. Yes.
Sounds fun.
That's so funny. I was gonna ask that's so funny. My question was going to be, and Harry, you're gonna appreciate this, like, if you were using the PG Analyze library, and if so, did that lock you into writing your gateway in C?
I can tell you it doesn't because I wrote it in Go.
No.
Yeah,
Yeah, so we wrote ours in Java with foreign function interface into C. And
That's enough.
I would not recommend it. Any startup, you sometimes make architecture decisions based on the strengths of the people on the team. If you have 3 Java developers, very strong Java developers in your startup, you may end up with more Java components than strictly make sense. It's also true, for example, the entire thing where we're going to touch the query planner as little as possible. We don't really have a lot of query planning experts. We have storage experts, we have extension experts, and we were looking at, if you look at CitusDB, they basically wrote their own planner, and it can kind of distribute things and then collect them and do aggregate, and we relied quite heavily on foreign data wrappers, in partially because we, okay, they had 5 committers that know what they're doing with the planner, and we were like, okay, we don't want to get into, we felt like we took on enough things that we will try to change as little as possible in the planner and do more work on the storage level, as, for example, and in the DDL interceptor was a large part of it, and a few other things. Yes?
So can you explain on how does that base to inheritance thing works? Like, is it goes to like one database and from there it figures out that these are the inheritance or these are the foreign table mappings and then it spans out from there?
Pretty much exactly as you said. So the query gets to one database. So it first, half of the union all selects from the local partition table. The other half, there is to-do base, it's an inheritance route, which means when you query from that, it actually queries from all the children.
Okay.
The children, each one of them is a foreign table somewhere else. So it's basically, and there is like a hidden extra union there that we're not doing and the inheritance logic is doing, essentially.
It's like the recursive thing that goes on kind of.
Exactly.
Okay.
Exactly, and the foreign data wrappers do what is called async append. So actually all of those are running in parallel and then they're kind of collected together. The other nice thing, note that there will never be any duplicates because every partition and every table belongs to a different tenant. It will always have different data. Union all is perfectly safe.
Thank you.
Yeah.
If I remember from what you said earlier, these tables are partitions into a larger table, right? So you're subdividing an existing, for this kind of a query, can you just query the underlying table rather than querying all other partitions and joining them? Or is that what's actually, I don't know enough about how the query planner works either, so.
Got it. Let me go back to,
Sorry.
yeah. So basically when I'm doing the union all, first of all, the local planner plans over all the partitions in the event spread. And then the hierarchical table basically distributes the query in parallel between all those foreign data wrappers. And getting
Oh, I see. The foreign data wrappers are the full,
are the inherited of
the top level full collection,
Exactly.
unpartitioned.
Exactly.
I got it. Okay.
And then when the query runs here,
Yeah, it makes sense.
plans for this set of tenants.
I
So
got
we basically distribute the planning.
This is what you were saying, that you can't mix partitioning and inheritance. And not everybody may not know, like Postgres has like partition tables, which are a relatively new feature of Postgres. For many, many years before that, Postgres had something called inheritance, which people effectively used to do partitioning. And it was like you'd have a table that inherited another table or a couple other tables under it. So you're mixing them. The bottom
Exactly.
ones are the events FDW2 and FDW3 are child tables of event space. There aren't lines, but like that's an inheritance setup. The top tables are partitions.
Got
And
it.
I think if I understood right, the reason you had to have like a union statement is because Postgres doesn't support like a
Exactly.
single mixed
Exactly.
partition/inheritance thing. So you have two tables, one with inheritance, the local one with partitions, and then you have these union all statements all over the place to put them together.
Yes, exactly.
Thank you.
This is exactly it.
Helpful.
And we don't, it's a bit of a hack. We don't love it either. And we definitely have ideas on how. The main reason why in Postgres you cannot mix inheritance and partitions is that partitions were supposed to replace inheritance, and nobody thought it's worthwhile doing the work to mix it. But it's actually not that much work to mix them, and we are planning to do what is needed, and it may involve more work in the planner in order to support this mix. Now I have to run for the lunch. Okay, we got here. Believe it or not, so far this was the easy part. It only gets worse from here. Moving tenants. This was the hard part. It's hard enough that we're not done yet. This is TBD. So I'm talking about work that is only partially done. We already did a lot to support it, but there may always be like, until it's in production and even after, there can always be oh crap moments. So don't hold me to this being the perfect solution. It is not yet in production. Okay, so let's, yes.
I had a question. I thought that with inheritance, you often have problems with constraints and indexes. Did you work around that?
We had problems with constraints and indexes, and we worked around it with what I haven't really talked about a lot in this presentation, which is our DDL interceptor, essentially. It's an extension that basically overrides DDLs, because one of the things, if I remember correctly, you're not allowed to put constraints on the base table. So we had to intercept those other table and constraints and make sure that they only apply to the child tables. So yeah, we have a lot of code and a lot of logic exactly to deal with it. There were also a bunch of bugs in Postgres around constraints and inheritance. A lot of them were filed with, basically it's like nobody is going to fix inheritance at this point. The future is partitioning. This is definitely something that I think will have to get sorted out one way or another, but
That's
yeah.
why I stopped using it.
Yeah, no, if we had a better alternative, I don't think I would be using them either. So yeah, this is just to be clear, this talk is not a recommendation of please use table inheritance everywhere. It could be used to solve a hard problem when you have that many different tenants and you have to isolate them, and you still want to query across all of them. So yeah. So let's say that you have a tenant and you want to move it. Why do you want to move it? Sometimes it's because our customer wants to move it. They may want, they know that this customer is important and they want to give them their own machine with lots of resources, or they have some kind of regulatory reason to isolate them somewhere like on a totally different machine. And sometimes, more often, it would be us in Nile wanting to move a tenant because we see that it's getting noisy and we don't want to impact anyone around them. So we find a more quiet machine for them to hang out in. No matter who is doing it, it's going to be update tenant. Remember when I showed you that the tenant placement table has the ID of the machine it's on? It's going to start with an attempt to update that. And then we have several things we have to do in order to move a tenant. One of the big challenges is that transaction IDs on the machines that the tenant is currently on is not going to be the same as transaction IDs on the machines that the tenant is moving to. And remember that every row has XID min, XID max. They're used in recovery. They have the rel XID, something that's also used in recovery. There are transaction IDs everywhere in the data itself. If I'm going to tell a Postgres, here's some data for this table, and the transaction IDs don't make any sense based on what is going on in that database, it is not going to start. So we had to make sure that Postgres never encounters transaction IDs that it doesn't know about. A good way to do it is if all the transaction IDs are, let's say, -2, which tells Postgres that they belong to transactions that have finished a long time ago and are not worth knowing about. In order to set every transaction ID of every row that is not currently part of an active transaction, we ran vacuum freeze. And remember, this happens only on one tenant. We do it across the board for partitions that belong to that tenant. Now we no longer have, most of the transaction IDs have gotten rid of. Next step is to detach the partition. Another great trick, it gets no locks. And for all intents and purposes, this partition is no more, but just to make sure, we also update the metadata. This tells our proxy that you have nowhere to route this tenant. At this point, this is where downtime starts. There are no more things running for that tenant. At this point, we very quickly store a bunch of extra information. For example, what transactions were in progress between the point while we froze things. So what is actually not frozen? This will be in the write-ahead log. We store the transaction IDs at the point of freezing, and then at the point of no longer having this tenant and killing all the connections. And we take all those and we basically store them on the side. Tenant moves over, and now we have to restore it. First thing we do is reattach the partition. Reattaching is yet another operation, a DDL that we invented and is serviced with a patch on top of Postgres. It basically says it's like attach partition, except that there is a data file. And here is the table space ID, here is the file ID, here's everything you need to actually access the data. And obviously, the data is over there in the page service and have not moved anywhere at all. Then we update the metadata, so everyone will know that this is the new location of the tenant. And basically, after we update the metadata, we start getting queries. Most of the queries will work fine, as long as they touch data that was frozen. The problem is we have some unfrozen records from the point we ran freeze until we detached everything. So if there were a lot of transactions in flights, there could be quite a few unfrozen records. What do we do with those? We cannot read them. They have IDs that don't exist in the new database. It will be a disaster. We are not allowed to read them. What we do is that if anyone tries to access them, our storage layer knows about it. They get frozen at the point of reading, essentially. So we update the ID to be frozen ID. Again, it means that all the xmin and xmax and all of those get ignored. And we can now safely access all the data. Any new transaction will basically set normal new IDs on those.
And here's why you move tenant one before the transaction is finished.
So we cannot move it while transactions are in progress, which is why we basically cut off everything that is going on at the proxy. We either wait for things to complete, and then we also get impatient after a few seconds and kill anything that is still in progress.
Why not freeze it then?
This is an attempt to minimize the downtime. If there's not many of them, then it wouldn't matter. If there's quite a few of them, then we're basically doing something that is a bit opportunistic, and we freeze them and clean them up when they are being read. Yes.
Have you added data to the table so that you know this is a table, this is a row that needs to be refrozen, or it was not frozen previously? It's in that window of between when you ran vacuum freeze and when you actually disconnected.
So we
how do you know that it's? I guess that's the question.
Excellent question. The XID is not going to be -2, so we know it's not frozen. But just in case, we also, if you remember in the last step of the previous slide, we stored in the transaction ID on the old machine where we froze, and then the transaction ID where we actually killed everyone and no more transactions. So we have this gap that we know about. And we stored the proper section of the write-ahead log and the commit log, so we can refer to them if needed. Basically, in order to know if this row is supposed to be rolled back, what is supposed to be going on with that. So we basically kind of, when I say that we freeze unfrozen records, we basically kind of play ahead from our copy of the commit log, so we'll know how to recover those in-flight transactions.
So you have to keep that chunk of the write-ahead log until somebody first reads the data, even if it's years later.
Yes. Definitely.
Okay, so this is a stupid question maybe, but this all sounds like a very error-prone process. And is the reason you do it this way so that you don't have to do something like a logical application to copy tenant one to the new server?
Yes.
Okay.
Exactly that. We didn't want to copy data. We think that leaving the data in place and fixing the IDs would be, we wanted the downtime to be essentially zero. And this was our way of minimizing the impact. Remember that if a customer wants to move a tenant, it's no problem. They can take however long they want, nobody cares. But if we want to move someone and they're being noisy, meaning that there probably are a bunch of transactions currently going on, we wanted to find a way to make it minimally disruptive. And that was our way of doing it.
Yeah, so you said one thing that when the update tenant calls comes in, you update all the partitions that tenant is present in, right? Or is there there should be a single partition where tenant is present in, right?
But each tenant probably has a lot of tables. Like each database has a lot of tables. Like if you think about there was Ben here who is his instructor. He's doing virtual classrooms, and if you think about it, it probably has a table with the list of students and grades and tests and recorded. Every one of them has to have a partition.
Partitions are per table.
Okay. Thank you.
And one of the things that we discovered with this structure, because few people here mentioned embeddings. Embeddings are freaking large, and embedding indexes are, well, first of all, they're not really real indexes. They are probabilistic nearest neighbor search structures. And it turns out that if you have several million of embeddings, it's going to be very slow to search them. But if you have one of those indexes on each partition, and each partition maybe only has a few thousand of those embeddings, then suddenly you have 1,000 reasonable size indexes instead of one gigantic index to search. So it's very efficient for those kind of hyped up trendy workloads that are typically a big pain to run in Postgres, especially if you also have those normal OLTP workloads. Okay, I have a long list of why I think it's cool. I have to, because it was a lot of work and it will be very disappointed if we come up with something that isn't cool. So we have all the tenants' data isolated to a list of blocks, and it gives us a lot of cool superpowers. We can back up a specific tenant. We can restore a specific tenant. We can even do futuristic things like create branches of the data of one tenant. So you can branch a tenant and then move it elsewhere and run a bunch of tests on the tenant's data without actually interrupting the actual tenant. So we can do all those cool things. We did manage to hold ourselves to our requirements. Single tenant query performance, it's just like querying a normal table, but we can still do cross-tenant queries. They're just slightly less or a lot less efficient. We can move things around. If a customer grows, we can grow with them and move tenants around. And it's extremely cost effective, because if you know that you are able to move tenants around with almost no disruption, it means that you can run machines that are much more packed than you normally would. Usually, you kind of have to leave maybe half of the machine in case someone goes crazy or grows really fast or something. In this case, we can pack them maybe to 80% and just leave enough resources to allow us to move someone when needed.
How long does it take you to move somebody?
From the point we start, it really depends on how much data we have to freeze in that first pass, but it's non-blocking, so they can continue working while we do the first freezing pass. And then it's, I think we got it down to under a second. I don't have the exact number right now. So, yeah.
I'm so sorry, Carl, a very silly question. Wouldn't it be less impactful if we move the ones that are less busy than moving the very busy one around?
Yes, but then we'd have to move many of them, and that would be a different kind of impact. So,
Fair enough.
like maybe there is a case where we can move a small subset and create enough space. So, yeah, right now our calculation on who to move is not the most sophisticated. We can definitely always get better algorithms. So, few things that are limitations. First one, partitions are partitions. It means that if we partition by tenant ID, you need to have tenant ID in every primary key. It sounds obvious. It sounds like something that you would even want to do anyway, regardless of if you're using nile or not. It turns out that I don't think we did anything that got more engineered pissed off at us than this decision. It turns out that I think both, so PHP has a very popular framework called Laravel, and Python has a very popular framework called Django. And both of those are not into making it easy to have compound primary keys. They want the primary key to be a single integer serial in every table, which does not lend itself into our type of distribution or partitioning or anything else we want to do at all. I see we found workarounds in both, but it's definitely not the way engineers who use those systems want to use them, and it's been an ongoing pain. In Django, I found a 25-year-old ticket with a long thread lasting about 18 years until people gave up, with a back and forth on whether compound keys are a good idea or not. In case you're wondering, I think compound keys are legit enough that no application framework should actively prevent you from using them, but here we are. And by the way, what's the situation on Rails? You mentioned that, someone mentioned that they're doing Rails.
It defaults to what you can do with it.
That's the way to go. Letting engineers do whatever they want at the end of the day is a good thing in ORM.
You also know the foreign keys then?
Yes, and it's actually the moment that it's in all primary keys, it's pretty much enforced that it's going to be on all foreign keys. Postgres will not let you create foreign keys without something that is also in the primary. So yeah, we have both. The other issue is that cross-tenant query performance is not great. The query planning with the union all is not always the most optimal. It goes into downright catastrophic if you do joins. So this is one of those issues that we're absolutely planning to tackle, because we're kind of like, okay, this is a temporary hack. We know we need to fix it. Yeah.
Is it triggering the generic query planner instead of, or is that the genetic query planner? Is that what it's called?
The genetic.
Genetic.
No,
Yeah,
I'm pretty sure it does not trigger that.
It's a threshold on tip.
but it's for joints. And I don't think for data wrappers where you're triggered.
Well, the question is partitions.
But
Not trigger. I think you're right though. I think partitions probably don't. Probably just joints, which would be why they're not. Okay.
Is it good or bad things that we're not getting it?
Good.
Okay. Now I have to go learn more about it.
It's another complicated solution to it.
Got it. Yeah.
Yeah, it's when you have like, it's kind of like 30 table join, and then like trying to, planner has to, the different number of combinations of join orders on that, it gets so big that they switch to a different algorithm that's statistical.
Got it. Yeah, we definitely have not run into this problem. I think the worst join scenario so far we've seen anyone try to do on our system was 7-way join, courtesy of Prisma, which somehow translated perfectly normal looking code into something with 7-way lateral nested joins somehow. But anyway, this still did not trigger any weird planning. And then after all the planning for a million tenants, we found ourselves with a system that we haven't tested it, but at least theoretically is limited to 16 million. Why 16 million? The table space OID is currently the main thing that limits us. We took a byte out of the OID. It's a 32-bit, as everything in Postgres. We took a full byte out of it in order to store the region ID. So we're limited to 256 regions, which we think should be enough. How many places in the world are there anyway? And then 16 million as the number of tenants that we can place after that. We checked the biggest multi-tenant system we currently know of. It happened to be Notion. They say they have 4 million tenants, so we figured we should be fine. The lower table name lengths, nobody complained yet. We hope nobody will, but our table names are limited to shorter than the 63. Yes, and since we compile our own Postgres, we could do it. So if anyone ever complains, we may do that. And then showed you all the complex paths for adding tenant and the fact that it has to add a partition to every one of the tables. If you have a lot of tables, adding a tenant will be slow. Deleting a table will be slow exactly the same way. And if you try to do truncate on this tenants table when you have, let's say, 1 million tenants and we have to go and drop 1 million partitions all over the place, it's not going to be super fast. Again, not something that people really complain about, but creating tenants is part of the application flow for many applications. So we are mindful of that one. So stuff we want to do in the future. So we have stuff that we want to do in Postgres, and then we have stuff that we want to do in Nile. So in Postgres, first of all, the union all thing, we really want to replace it with an actual mix of partitions and hierarchical tables, or maybe better rules about foreign partitions that will allow us to have sub-partitions, but some are foreign. Postgres does have support for sub-partitions, but we cannot mix them with foreign tables in quite the way we want to. We're going to work on that. The lightweight partitions. This is one of the things. We love partitions. Obviously, we couldn't do most of what we do without them, but they take up a lot of space in the catalog. And if you have a connection pooler and every connection starts touching a lot of partitions, of the memory of the catalog cache in that connection will grow and grow. Fun fact, there is nothing in Postgres code that limits how much memory is used by a backend connection process to store the catalog. So if at some point someone ran a cross-tenant query and this catalog blew up, it will stay gigantic. And if you keep connections open for very long, which in general is a good thing, eventually every one of them will become gigantic and take over the entire memory of your machine. We don't love the idea. We had two things we thought of doing about it. One of them is what I explained earlier, to completely rewrite the query planner so we won't really have partitions. We will have basically each table, instead of having one table space, will have an array of table spaces, and the storage manager will pick the one that is actually getting queried. Maybe one day, we'll see. The other option is to have some kind of an LRU structure for the catalog cache, which may make more sense. Yes.
Proxy recycle connections.
Sorry?
Does your proxy have like a maximum lifetime?
Yeah, now we have no choice, right? So currently the lifetime is not by time, but by how many queries ran. So after a connection was used to, I don't remember, like maybe 500 queries or something like that, we get rid of it and bring in a new one.
So that would help mitigate the memory bloating a little bit.
That's exactly why we have
This is-
yes.
This is the reason it's in the happiness sense to set like in PG Bouncer or like connection poolers having like a max, because it's not, it's like a, this is a Postgres thing, it has been forever. Like
Yes.
memory bloat on connections.
Yeah, we've run into that here also, to where I've had to set it up that it will kill idle connections because the application will run the puller and use up several hundred gigs of RAM. The next connection, a day or two later, will use up several hundred gigs of RAM. Now you're using double that, and eventually you run the machine until the OM killer comes and kills Postgres.
Exactly.
And so we've had to limit it down. And that's why at the dev conference last year, when they were asking for feedback, I was saying, hey, they need to make some adjustments and stuff. And what they ended up coming up with is that they said they would work on is to the PG stat activity, adding how much memory is being taken up by that connection, so that when in the future, when people update their connection pullers, they can say, okay, this connection has been returned to the connection puller and is using this large amount of RAM, and then you say, okay, now it's time to recycle it. So I'm hoping that will come out in one of the near future versions of Postgres, because we were talking about it at last year's dev conference.
Thank you. And it's funny how similar things keep coming up more or less every year. Yeah, the other funny thing is that, like most things in Postgres, if you're wondering where did this behavior come from, and you search the mailing list long enough ago, you always find like 15-year-old email from Tom Lane saying nobody ever uses more than 5,000 tables, and if they do, they probably know what they're doing, so we don't really need to worry about memory management for those kind of people. And kind of partitions were not invented yet when this mail was written, and 5,000 tables were probably unimaginably large. So who really needs a limit on the cache size when 5,000 tables is the most we can imagine?
How times have changed.
I know.
That's any PeopleSoft installation will have that many tables.
Yeah.
So
Easily.
I have like a different question, but did you have more stuff, or because I want to ask about extensions.
Yeah, so let me finish this one, and then I'll do a quick summary and then open it up for questions again. So we did have to do extensions, and we were missing two critical hooks. One is a way to hook into the query planner before it replaces all the names with IDs. Not super critical. We found workarounds for all of it, but it would be nice to have one extra hook there. The more serious one is the storage manager extensions. Storage manager does not have extensions. It is unextensible. You cannot replace Postgres storage manager unless you are going to patch Postgres. As far as I know, Nile is the third or fourth company that basically applies a bunch of private patches to be able to override the storage manager. And we used patches that were contributed by the team at Neon, and I believe it was contributed over 2 years ago. And they sit there like many patches. So for me, I think if there's one thing the Postgres community should really do is allow people to experiment with storage layer ideas the same way that the extensions are amazing in the ways that they let us override DDLs and implement our mix of partitions and hierarchical tables and do all those things that nobody really wants in core Postgres, but we found really cool and we can do them. The only thing that we cannot really experiment in the same awesome extension way is the storage manager. So I really hope this part will get resolved. And then in Nile, we're basically just looking for more ways we can use the isolation and the system we built to bring more value to our users. So things like per tenant statistics. If you want to know not just what queries are popular and use a lot of resources on your database, but also who is running them. If this query is slower for this tenant and faster for the other tenant, and you want to investigate why. I don't think there is a single person who worked on a multi-tenant system that didn't have this query that was fast in testing and fast for everyone else. And this one customer kept complaining that it's slow for him and you couldn't really reproduce it. So having this ability to clone the tenant, get statistics for a tenant, to be able to understand what's going on this level, I think I want this feature a lot. So to summarize, first of all, Postgres, don't take this talk as Postgres doesn't scale. Postgres scales amazingly well on one machine. Again, you can have a multi-tenant application and a $2 billion company and be on a single Postgres. So as long as it works for you, do it. And a lot of the reasons why it doesn't work have much simpler workarounds. Like 90% of the time, it's tuning vacuum and being careful with toast, and you're all good. Read all the happiness hints, because it may be one of those as well. However, if you do need to scale out, SaaS workloads are fantastic for sharding by tenant ID. So this is what we went with. And for doing the partitions by tenant and decoupling storage from compute, it gives us isolation, it gives us elasticity, it gives us scalability, it gives us performance. It was a lot of work. It still is a lot of work, but we're generally very happy with the way it went. Okay, now I'm open for questions.
So I'm curious, I didn't see a way, in the way we do it, it seems like it wouldn't work with this, to do change data capture. Do you have that on your roadmap?
We do not currently have a way to change data capture. We have a plan on how we can do it, which is kind of a service that goes over the wall and kind of splits it into separate tenants kind of thing, but it's basically a whiteboard doodle at this point.
Every table has a primary key that includes the tenant ID to be able to take the one feed and matrix it out. Right?
Exactly. Yeah. This is exactly.
I realize you've only drawn it on your whiteboard compiler is broken. I understand.
I heard that LLMs can now generate code from whiteboard drawings, so I'm sure it's all fine.
Yeah, I'm sure your team probably has it done already. But it does. But that doesn't sound like a particularly hard to overcome problem. I mean, you got to grind it out the code, but it's not like it's going to fundamentally change.
You have a surface-free wall, you can split it in there.
Yeah.
And I don't know. I mean, I'm sure someone said that there is always employment for people who know Postgres, but just in case you are really interested in joining Nile and actually doing the whole change data capture thing, we're pretty. The main bottleneck we have at this point is basically people to actually build those kind of things.
My question on the extensions, so Postgres has lots of extensions that people will want, PG cron, well, you mentioned kind of the AI PG vector stuff, so it sounds like I'm curious like how much you've done with kind of extension support, and more specifically what I think would be interesting is like what are the characteristics that make an extension easy for you to support, and what are the characteristics that would make an extension a lot of work or impossible for you to support?
Oh, that's a fantastic question. So yeah, we support a large number of extensions, and we run. I mean, most of them are not a problem. The ones that are more difficult for us to support are, first of all, anything that exposes internals. We are kind of like, okay, our internals are very different, as you've seen, than what we actually show customers. So anything that exposes internals is often a problem. And then some extensions were just super heavyweight. I was trying to remember one, like I think PG audit. It just takes a ridiculous amount of CPU and memory, and we're like, okay. Maybe we'll keep it on just the dedicated machines for if someone is paying some extra and it's their CPUs and not something that we're not trying to kind of create a serverless experience. I think there were some that we thought are security hazards in some ways, but I don't remember which ones. We were like, this doesn't look safe. And there is another weird thing. If you're a vendor, like running Postgres for other people, I don't know why, but they think that you actually wrote the extensions that you're using. So there was a really nice extension that just exposes a bunch of statistical functions that, like average, but for financial transactions, so they have their own average kind of thing. And it had a bug. So sometimes whatever statistic it was calculating would come out wrong. And for some reason, people think that I'm responsible for a bug in that random extension. And again, if it's one of them, it's okay. But if you have 50 or 100 or 300 of them, theoretically, every one of them can have more than a single bug. It gets quite a lot. So we're still trying to figure out what to do with bugs in someone else's code and how much ownership we take over extensions that we all, from my perspective, all I did was install them. Yes?
So if you're in the real world and you have an app and you decide to deploy a new version of your app in canary mode, meaning a first set of tenants that get a new app, how do you deal with schema change, schema requirement? Does it mean that if you add a column or change the width or whatever you do, does it get forced to all the tenants, or can you go progressively? That's one question. And second question, if you make a schema change, does a change of the schema affect the speed for everybody, or does it roll through all the tenants?
So, okay, let me take it back a step. We built the system for just doing those distributed DDLs across everyone. So we basically do it transactionally for everyone at the same time. We gotten a lot of requests, as you said, that I want to make schema changes just for particular tenants. Sometimes it's slow rollout. What is even more common is that apparently, like if you have a JSON schema, not all your customers will have the same data in the JSON. They will not have the same fields in the JSON. So you're like, okay, this tenant has this extra field that nobody else has, and I want an index on that specific field, which only makes sense for that particular tenant. So we are going to do some work to support this kind of, schema change for a particular set of tenants. And then it'll be up to the developer to manage the entire thing, which I'm curious how it's going to go down. In terms of slowdown, if you do something that takes a lock, it is going to eventually take a lock on everything. It may be we hold the locks for the duration of the DDL. So if you do something slow and it takes a lock on all the partitions, then you will feel it. Like everyone is going to feel it. We do some optimizations for that. For example, at the start of a DDL, we treat every DDL as a transaction. We try to take locks ahead of time with very, very short lock timeout. If we fail, we retry. We're trying not to create a huge backlog. So a lot of the best practices for doing DDL safely with locking, we try to apply this automatically. But if someone begins a DDL transaction and do a begin, do a alter table something, and then go grab coffee, the lock will remain there for the duration of the developer getting coffee and not until they come back and do a commit.
Across all tenants?
Yes. Yeah. We are not, right now we're not built for a situation where different tenants have visibly different schema. So yeah, this is the thing that customers have asked us for, and we're going to have to add support for.
It's already very impressive what you do.
Thank you.
Could you go back a bunch of slides to the one where you're showing the mapping of the foreign data wrappers across all the different, that one. Yeah, so I've done something like this before, and it wasn't much bigger than this, and it was a pain to maintain. When you guys make a new node, do you have to go update all the, make new FDW for every single existing node?
Absolutely.
Yeah, is that also a pain for you, or?
So the transaction coordinator does that because it already knows to do DDL across all the nodes anyway, like that's what it does. So we basically reuse that. This is something that we do all the time now, and it's not particularly painful. So we did something fairly cute where we run all this mess on Kubernetes. So basically Kubernetes knows how to deploy a new Postgres, and it also calls some REST APIs that live on, actually not even REST, it's a our transaction coordinator is in Rust and speaks in protobuf. So it calls some protobuf APIs, gRPC I guess, on the transaction coordinator to say, okay, the machine is there, it's running Postgres, it's alive, it's healthy, now go do your thing. Here is a list of tenants that are supposed to be over there.
And does it use like a two-phase commit to make sure everything is consistent across the whole?
Exactly.
Okay.
Exactly that, yes. And it's a different presentation, and you can find it online, how to do globally distributed DDL in Postgres. But we basically use the pre-commit hook in Postgres. So we have pre-commit and we have commit, and it's perfect for two-phase commits.
This is why you hate the create table space command.
Exactly. We did all this work to hook directly into the transactions and do all those transaction DDL, and we couldn't reuse it for table spaces. And I don't understand, if anyone has any idea why table spaces cannot be done transactionally?
Well, I think can you add that to your list of things to do in Postgres?
Right, yes.
I think it's because the file system is not, it's outside of transaction, Postgres is transaction viewpoint, right? Like you can't control anything in a file system.
That's true, but then like, for example, extending a file does
But that's in the
happen.
wall log, whereas I don't think a new table state does it make it a wall log? I don't remember.
Tables are files
But-
though, I mean.
The tables are, but table spaces,
It's like a
are those
directory.
directories. I don't know.
That seems like a weak excuse to me.
Exactly.
Sorry, it's just like a,
Hey man, don't.
If that's,
He's guessing. He's guessing.
I don't know, I'm saying,
I don't
get it,
know.
I'm not
That'd be a
looking
windy
ahead.
excuse.
If that was the mailing list thread, we should.
Change that. Patches are accepted.
You can get it. I mean, I'm sure that your top end for a single node
Yes.
is very large.
Yes, it turns out that you can abuse Toast quite a bit. Like Postgres supports binary bit arrays, I believe, and people put all kinds of stuff in Postgres. Yes.
So if I understand properly, when a query is being done, it's going through your query manager first.
We don't have a query manager.
The reason I'm asking that is that in some application, multi-tenant application, it's possible that the application developer would like to give their client the ability to do additional queries. The problem is they could, in theory, put an ID of another tenant in their query, and in theory, query other tenants' data. So if you capture all the queries, could you add some kind of lock-in so the
Yes.
tenant ID is fixed in a certain context?
Yes, we absolutely do it, and we actually do it twice. So let me get to the relevant slide. So basically, the next one. Is it better for that one? There's two places where we figure out where you connected to and who you're trying to act. The first one is in the proxy. It does parsing. It pulls out the tenant ID. It knows how you connected. If you connected to a specific tenant, it will block you if they don't match. We don't love the parser in our proxy. For a bunch of reasons, it has a lot of drawbacks. Nile.dev is an extension. It actually uses it hooks into the real Postgres parser, and it applies this check once again, which
And-
tenant are we working on and what is actually in the query, and make sure that they match, fail any query where they don't.
Or you can always add an extra N at the end.
Yes.
Thank you.
So the like live migration of tenants you said is a feature that you're working on. Do you have like a more manual process right now, and this is just kind of a more automated thing?
Yes, we have an extremely manual. We
Yeah.
believe in doing things manually and then automating them.
Yeah.
And in this case, as you notice, there's so many moving parts that we really had to make sure they work before we invest in automation.
So I would imagine that like this is I love this whole talk because people constantly are like, I think I need a sharded database. Now I have 10 more things I can tell them aren't going to work on there. It's just not. Everybody thinks it's just like a button you push and it's just like magic and transparent, and they don't realize that like adding a tenant ID has to be on every query and every table. And like that little gem about how like there's actually frameworks that make this difficult is brilliant. But the like rebalancing and hot shards are like, this is just a thing. Like if you've done any distributed computing, it's a thing. But what's interesting about it is that like I would imagine that like the shards you have to move are probably going to be the most difficult ones. They're going to be the hot ones, right?
Exactly.
Right. So like, is that something? I don't know. Is that? And the thing with automating is like the thing that you're gonna have to move is gonna be the thing with the most activity. That is the biggest. That is the hottest. And like so. It's like the one riskiest thing where you're gonna have you're gonna run the vacuum, but there's gonna be all this churn while the vacuum's running. The wall log's gonna get really big. There's gonna be some record that sits there, you know.
So this is something, rebalancing is something that I worked on a lot in the past, like not in Postgres, but
in Kafka. Or?
In Kafka. That was basically one of the big projects that my team and I worked on. And there were two important lessons that we learned out of that. The first one is that you leave headroom. So you do not run machines at 100% capacity. You check how much you need in order to move stuff around, and you leave some headroom. The second is that you, in order to keep this headroom, you basically continuously move some stuff. So you don't wait until things are absolutely on fire to move, because yes, you're not going to be able to move them at that point in time. You kind of gradually shift things away as they heat up, and you may have been lucky and moved the ones that is going to become hot. You may have moved some others, but created more room.
Because you said it's a fairly manual process. You guys just like have a calendar block
right
Friday
now,
afternoons that.
So yeah,
party
right
line
now
and
we are
move
not doing it
shards.
that way. Right now, as I said, like we are doing it in emergencies only. But yeah, the plan is to. One of the goals with this automation, and also with the fact that we really want it to be zero disruption to the customers, is that it will allow us to continuously rebalance.
You didn't want to just do like a recurring meeting and buy everybody snacks?
Sorry?
You didn't want to do a recurring meeting and buy everybody snacks on Thursdays while they rebalance the shards?
You joke about that, but that happens in startups.
I don't have a snack budget, so.
We have also found when we're moving hot shards around, right, that as you move the hot shards, they tend to stay hot, and then things don't move to join them later, right? And so eventually things separate out naturally, and then they kind of stay separated.
Have you guys done work like around automating it, or is it mostly manual?
We have a highly scripted process that we run manually. And we would love to automate, but I mean,
I'm familiar.
yeah. When you're moving, it's like with everything in the database, right? There's parts that they have so many potential failure points that it takes a while until you're ready to say, okay, now you run by yourself, and I'm not even going to watch you anymore, right? So yeah, we're getting there. Not quite there yet.
Other questions for Gwen?
I have a very maybe silly question. Imagine what if the tenants want to do A/B testing on 10% of their original data. Is it possible for them to just ask you, hey, can you please like give us like 10% of that, put it in like its own chart so that we can like do our own analysis on it much more thoroughly? Is that something you guys will be okay with?
I don't think so. I don't think we have any plans to work below the tenant level, but we can give you a shard with a copy. And if you want to drop 90% of your copy, it's up to you.
You talked about doing the branching. Would you be able to do the branching kind of stuff when
Yeah.
that stuff is online?
Yeah, that's our plan essentially, and like basically do kind of copy and write of a specific tenant. Yeah, it's funny with copy and write because then getting 10% of the data is actually a lot more overhead than just keeping all of it.
Oh.
Because the delete is what is actually going to cause the branch to materialize.
Yeah, but if you had a branch, you could just select 10%, but not actually delete the other.
So if you ever need that, then definitely select the 10% and insert into a new table and don't try to delete 90%.
It just seems much smarter to do A/B testing on a small section than as a whole every single user of their like company or whatever. So that just seems like.
Yeah, no, it makes sense. I don't see us support something below the tenant level, but if you want to experiment on 10% of your tenants, is Eric or Eric, as Eric here suggested, then we do want to allow this kind of thing.
Okay.
Very difficult to do that because of the relationship that the offer writer is.
Thanks.
All right, Gwen said at the very top of the presentation that she's giving this talk again next week in Vancouver. So if go find her afterwards if you have any feedback for her, just since you requested it specifically, thoughts about just feedback for the talk next week. And thank you very much, Gwen, for coming.
I will say, so the Postgres Extensions Day in Montreal is May 12th. Then the Developers Conference is May 13th through 16th in Montreal. And then the New York City one is in September, and I accidentally just closed my tab, so I don't know the date. But I had it there.
29.
So it's so yes, you can look those up. So yeah.